Here is something strange about the laws of physics. Every equation that governs matter, Newton's laws, quantum mechanics, Einstein's relativity, every single one works equally well in both directions of time. Film a billiard ball bouncing. Play it backwards. Nothing looks wrong. Film atoms colliding. Play it backwards. Still perfectly valid physics. The equations do not distinguish past from future. They are time-symmetric. And yet, you have never seen a shattered cup reassemble itself. You have never watched smoke flow back into a candle. Time, in our experience, has a direction, a definite, one-way arrow. Where does that arrow come from? If the laws of physics are perfectly symmetric, how does asymmetry enter the world? The standard answer invokes entropy, a measure of disorder. In 1865, Rudolf Clausius stated the second law of thermodynamics. Entropy tends to increase. Things become more disordered. Heat flows from hot to cold, never the reverse. Ludwig Boltzmann gave this a deeper explanation. There are simply far more disordered arrangements of atoms than ordered ones. 1,000 puzzle pieces dropped randomly are almost certainly scattered, not assembled. So time flows forward because entropy increases. This seems satisfying, until you ask the next question. Why was entropy low in the first place? The second law says entropy increases, which means it was lower before. Trace it back, and you reach the Big Bang, an event of extraordinarily low entropy. Astonishingly, implausibly, cosmically ordered. Boltzmann's explanation tells us why entropy increases. It does not tell us why it started so low. That is the real puzzle. Boltzmann himself recognized the problem and proposed a terrifying solution. If the universe is infinite and eternal, then by pure chance, fluctuations in entropy will occasionally produce ordered regions. Our universe might be one such fluctuation. But this logic produces something disturbing. A brain-sized fluctuation, just enough neurons to produce one moment of false memories, is vastly more likely than a universe-sized fluctuation producing a consistent history of 13.8 billion years. If you were a random entropy fluctuation, you would almost certainly be a Boltzmann brain. A momentary mind blinking into existence with false memories of a world that never was. The fact that we seem to exist in a coherent, consistent universe. This is deeply improbable under Boltzmann's hypothesis. His own solution seemed to predict that we should trust our own observations. Something is wrong. The physicist David Albert gave this a name: the past hypothesis. To explain the arrow of time, we must simply assume, as a fundamental initial condition of the universe, that the Big Bang had extremely low entropy. Not derive it, not explain it, just assume it. Every asymmetry we observe, every cup that shatters, every candle that burns, every moment of irreversible change, ultimately traces back to this single unexplained fact about the beginning. Why did the universe start in such an unlikely state? Physics has no answer. Cosmology offers speculations, but none of these derive the low entropy beginning. They push the mystery back a step, or simply accept it as brute fact. The arrow of time is not a consequence of the laws of physics. It is an assumption we feed in from outside.